Hey guys, welcome back to another episode of Who Asked You Anyway? This time we have a 2013 Nissan Leaf battery module here. And are any of you old enough to recall fish in a can or sardines? These really remind me of the sardine cans. Yes, they're slightly oversized, but that's what they remind me of. And I point out that this is a 2013 because it is slightly different than the 2011 and 2012 models, but that's neither here or there. So what I find interesting about this battery, it stores electricity or energy in a form of DC like all batteries, but as far as I know, batteries have two terminals, a negative and a positive. So what the hell is this? What kind of white rhino are we dealing with here? Well, let's go explaining this like we usually do by first heading off to Target. So just as before, we're going to explain this battery module using some AA batteries. This one here is configured in what is called 2S 2P. What the heck is 2S 2P, you ask? Well, let's talk about it. So when it comes to the 2S part, that means how many cells there are. The number in front of the S is how many cells. Okay, so we know that we're going to use two cells, 2S, so we have these two AA batteries. That's our 2S, all right? But wait, it says 2S, 2P. So let's use some lumber analogy. We've all heard in the States of a 2x4, very common size for wood in woodworking. You can have a 2x4 by 8 feet, 2x4 by 10 feet, 2x6, 2x8, 2x10. You get the idea. So when you see 2S, 2P, think of it as 2 by 2. So it's 2 columns times 2 rows. And there we have it. There is our 2S, 2P. Two cells, 1, 2, in 2 rows of parallel, right? 2 parallel rows, 2P. So there we have it. Now, to represent this a bit more logically than physically, but kind of get a happy medium, we have our negative here, we have our positive here. So let me flip these around. Okay. So we have our negative here, these are negatives, our positive here, these are positives. But there's this middle terminal. Now I'll try to explain this in more detail in another video. But for now, if we were to kind of visualize how they're connected in there, it would sort of look like this, okay? If we were to put our multimeter on the positive, it would be like connecting to these here, which are connected together, the positives are connected. And if we were to put our negative meter over here, then it would be like putting a multimeter on these two negative ends connected. Let me raise this a little bit. Okay, the middle row here is as if we were to put a piece of metal, which is called a bus bar, across these two negatives and these two positives. The middle guy here is what connects these in series. So it just staggers them like this because there's 4 layers of cells of these flat pouches in here. And I'm trying to represent them and demonstrate them using these cylindrical shaped batteries, but this is sort of the idea. There's 1, 2, 3, 4, and there's 1, 2, 3, 4 layers of cells, and the middle one here connects them. And what's really neat about this is if you wanted to check just the top cells, you would go from here, this would give you the negative, to here with a multimeter, and that would give you 4 volts for these. And then if you want to measure the bottom cells in here, you go from this negative or this end to here, which would only measure the bottom 2, and that would give you another 4. So when it comes to this cells, I call them 4-volt cells. They are about 4 volts. So anywhere between like 3.8 maybe to something like 4.2, but just for easy math, I call them 4 volts. And another thing, give you a top tip when it comes to 2S, 2P. If you want to find out a voltage of any type of pack and you see its configuration, be it 16S 1P like our prior BMW module, or 2S 2P, or 8S 2P, you take the number in front of the S, multiply it by 4 volts, and that will give you the voltage of that module. So this is 2S 2P, so we take the 2 in front of the S times 4 volts. So 2 times 4 volts is 8 volts. And this measures approximately 8 volts. Okay. Despite there being 4 cells, they are in parallel. So we only take the 2 in front of the S. Okay. And then what does the 2 in front of the P mean? Well, that means double the density. So if it's 1P, it's a certain amount of energy or density. I'm not going to get into how much, but let's say it's 10 of something. Well, if 1P is 10 of something as far as energy, then 2P would be 20 of something, or double that. There we have it, the 2013 Nissan Leaf module, 2S, 2P explained with AA batteries.